This section we're going to test two means using small samples, so both sample sizes, or at least one, will be less than 30. So what we're going to do is we're going to draw two independent samples from normal populations, and the populations will have means mu1 and mu2. Now we're going to make the assumption that the standard deviations are the same. Now we can always test that using an f-test, which we will get to in some time, a few weeks. But this is typically true in most instances, so it's a reasonable assumption to make. Now, in our samples, we're going to have sample mean 1, sample size n1, sample mean 2, size n2, and then we're going to estimate the common standard deviation with this expression right here. Now, the test statistic that we're going to use, the measuring device that we're going to use to test the difference, the discrepancy between the observed difference. Now, here's the observed difference, right? x1 bar minus x2 bar. That observed difference and the assumed difference. Now, the assumed difference will be mu1 minus mu2, right? The assumed difference between the population means and the observed difference. So the test statistic is going to do this. It's going to take the difference between the observed value and the assumed value. That'll give us a number of units, and then we'll divide by the number of standard deviations. Now, this is the number of standard deviations here, right here in this first one. So what we do is we take a unit and divide by standard deviation. So the whole thing comes out in a z-score in standard deviations. So t is the number of standard deviations away from this value that this is. Now it is a t distribution, so we've got degrees of freedom. Degrees of freedom is the sum of the sample sizes minus 2. And then what we're testing is typically this. H naught will state that mu1 minus mu2 is 0, or that means what? No difference? The difference is 0, so no difference between the means, or that just means that mu1 equals mu2. Now, if this is what we're going to test, that mu1 minus mu2 is 0, that means up here we can just drop that. So in general, you don't have to test that there's a 0 difference. You could test that there's any difference, like 5, 10, 300, whatever. So this is the general formula, but typically we're going to be testing no difference. So we can just drop this term, and I can shorten up the formula if I just write all of this as S. So our general formula is up here at the top, that big one, but the shortcut formula, the shorter version of writing it anyway, is this one down here. Now, we are not going to get involved in all these computations. We're going to use the calculator. We're going to input the numbers on our calculator and have it compute the p-value, right? So what we're going for is this. Get, well, let me see if I can spell it. Get the p-value, and from the p-value, we'll make a decision to reject or fail to reject. So let's run an example. In fact, I'm going to do the same example as we did in the very last section with these companies A and B. And company A claims that it has medication that reduces pain faster than company B's. I'm just going to change one thing here. So we're going to make this assumption that we take random samples of size. Now, in this problem, we're going to do not 60 and 42 like we did the last time. Let's make small samples and run 16 and 8. All right, so here's our sample mean of company A. They got a mean of 20.5 minutes with that standard deviation. And for company B, their average time for pain relief was 22.1 minutes with that standard deviation. Now we're going to test that there is the difference between the mean time for pain relief in company A and the difference between the mean times is 0. That means no difference. Versus the claim, the company's claiming that theirs is faster. So if I take the mean time for A, subtract the mean time for B, I should get a negative number, right? Because A is supposed to be faster, so smaller number. Smaller minus larger is less than 0. Or if you like, just the mean time for A is less than the mean time for B. So I'm going to go to Stat, over to Tests. This time I'm going to choose item number 4, which is 2 sample t-tests. And choose Statistics, because we're putting in the statistics, we're not putting in data. Now let's put these numbers in. So X1 bar, this is the mean from company A, and that is, let me be sure I get it right here, that is 20.5. That standard deviation is 9.1. Sample size now is 16. Now, the mean from the second company, the mean from the second company is 22.1 minutes. That standard deviation was 8 minutes, and that sample size was just 8. Now, what about this? This is how we're going to compare. So how does mu1, this is the mean of company 1, or company A in our case, how does that compare to the mean of company 2, company B? So is it not equal, is it less than, or is it greater than? Well, we're going to say it's less than, right? Because the mean time, if the medication really does act faster, the mean time should be less than. So we're going to choose less than, right? So get your cursor over here and press enter. Choose that one. And then pool, because we're just combining this as one big sample. And then we're going to calculate. And then when you calculate, right, lots of stuff comes up. Here's the one we're interested in. The p-value is 0.3387. So what does that tell us? Well, we need to choose an alpha. So why don't we choose alpha to be 0.05? Use 0.1 if you like. But now what we're going to do is we're going to compare P to alpha. All right, so I'll write a table, P and alpha. P is 0.3387. Alpha is 0.05. So P is greater than alpha. So what do I do? Well, here's how I think about it. When I see a greater than sign, I think greater or high. It's a high value. And we're dealing with probability, so I'm thinking I've got a high probability. Now, that means I have a high probability of seeing the observed value. Given that the claimed value is true, or given that the H0 value is true, I have a high probability of seeing the observed value. So if I have a high probability of seeing that, I think that's probably not unlikely. Right? That is not going to be an unlikely event. And if it's not unlikely, I will fail to reject. So our H0, now I'm going to go over here to the other side of the page. Our H0 is that there's no difference. And what are we doing? We are failing to reject that. But we have to write this conclusion up in terms of the way the problem's written. So the problem says that company A claims that its new medication is faster. So really, the claim is here, right? This is the claim, is this one. So we're rejecting that one, right? We failed to reject, got to be careful here. We failed to reject H0. So we're not rejecting this. So we're kind of going with this. But that means we're going to reject this company's claim. So let's write our conclusion this way. Let's say at alpha equals 0.05, this sample indicates there is not enough evidence to support company A's claim that its new medication works faster than company B's.